Okay, today about introduction to alkyne reaction. Okay, alkyne reaction. If you have alkyl compound, the alkyne compound, it will be useful for any reaction to be entered to the any type of the reaction. Okay, the first one, as we agree before that with you, if you have any question, please ask me. I will explain slide by slide. He said, oh, the reaction of alkyne occur, okay, occur because they contain easily broken pi bond. We know pi bond is not very strong bond like sigma, okay? We know that the pi bond is easy to be open. For this reason, the alkene and the alkyne compound, it will be active, okay, toward the addition reaction. You know that. In the case of the terminal alkyne, okay, the terminal alkyne, we know the terminal alkyne is acidic compound, okay, the proton and the carbon, if you have a proton here on the carbon for the terminal alkyne. What meaning terminal alkyne? Meaning the triple bond at the end of the chain, okay? That meaning one of the carbon, a triple bond with hydrogen atom. That meaning the hydrogen atom here on this carbon, it will be acidic hydrogen. We say it acidic proton. Why? Because it will be can remove and give you conjugated base, and the conjugated base, it will be stable. Why? Because the sp characteristic. And you have this question in your exam before that. Now, the first type or the type of the reaction can be entered by the alkyne compound is the addition. Yes, the addition reaction. Why the addition? Because the alkyne is unsaturated carbon, okay, unsaturated carbon with double bond or the triple bond. That meaning can be accept atoms or accept electrophile, okay, to be added on the double bond or the triple bond for the unsaturated compound. Now here, he said the addition reaction. Like alkene, we talked about alkene before that. Alkyne also can be entered the addition reaction because they contain weak pi bond, okay? But here we have a pi bond. That meaning we have two bond pi bond. For the alkene, if you remember, we have just one step addition. Okay, because we have just one pi bond, but here we have two pi bond. That meaning we can do two-step addition. Okay, step number one addition. Okay, XY. That meaning that the triple bond, it will be converted to the double bond, and the XY, it will be added on the carbon. Now another, because we have another degree of unsaturated, we can accept another molecular. Okay, can be also, it will be added on the carbon double bond to give you sigma bond and XY. Okay, that meaning the overall total result for this reaction, it will be added 2 moles of this compound. Okay, 2 moles of XY, 2 mole of XY by two-step reaction. Okay, not one step, two-step reaction. I hope you understand this. If you don't have a question, I will talk about the terminal alkyne reaction of an acid. Now, terminal alkyne, okay, reaction and acid. We know the terminal alkyne can be do as bromistid acid. Why? Because the conjugated base, acetylide anion, will be stable. Why? Because the sp characteristic for the carbon atom. Now, if you have base, the base attack the proton. Okay, take the proton from the terminal alkyne and to give you acetylide anion. Okay, to give you acetylide anion. And then at the end of this chapter, we have some reaction. This acetylide anion, talaba, if you cannot, can be do as nucleophile. Okay, it will be react as nucleophile. This part, it will be react as nucleophile. You can write here nucleophile. It will be react as nucleophile. This important. And the end of this chapter, we have stepwise synthesis for some compound. Okay. And he said, what base can be used for this reaction? Any base, strong base or weak base. Because an acid-base equilibrium, look, we have equilibrium here, favor the weaker acid and base. Only bases have conjugated acid with pKa value higher than the terminal alkyne. Okay, only the weak. And look here, if you have this butane, okay, methane, ethane, propane, butane, with طبعا 2 pi bond with the triple bond. If we added 2 mole HX, okay, the product, it will be H here, the proton here, the hydrogen here, the hydrogen here, and the halogen, the 2 of the halogen, it will be bond at the same carbon. طبعا why the X hard, why the 2 halogen atom, it will be bond on the same carbon. طبعا this you can write here not according to the Markovnikov rule. According to the Markovnikov rule, because the stability of the carbocation, we know, you know that, okay? You know the stability of the carbocation. If you added if you remember the addition of HX for the alkene compound, the proton, it will be added on the less substituted carbon. Okay, now you have 2 carbon here, 1, 2. Anyone is less substituted carbon, this. Okay, and this carbon, we have alkyl group bonded to this carbon. Okay, that meaning the proton, both of the proton to be added on this carbon, to the less substituted carbon, with to the carbon with more hydrogen. That meaning this reaction, talaba, according to the Markovnikov rule. Now, if you have X2, 2 mole X2, no problem. It will be X, 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 X. Okay, there is no different. Okay, there is no different. That meaning 2 mole of the halogen, like chlor Br, it will be give you full addition on the triple bond halogenation. And you know the mechanism of the halogenation. Okay, also you know the mechanism of this. But we take the mechanism as fastly just. Now, the addition of the hydration, we said hydration, the addition of the H2O molecule. Okay, we know the H2O is very, can do like acid, can do like base. For this reason, is not very strong base. Just H2O alone cannot be react with the alkyne because it's so weak. For this reason, we need catalyst. The catalyst here is the H2SO4. Okay, the H2SO4 acid. The acid is catalyst for the reaction, and it will be give you ketone. Okay, why ketone? Why we know for the addition of the alkene. If you have alkene, give you kuhul. If you remember that. Okay, you can check the last lecture. Okay, if you added the H2O by using catalyst for the alkene, give you kuhul, but here give you ketone, not kuhul. Why? We will take the reason why, because the enol ketoenol tautomerism. Okay, we will take it for the few slides later. Also, you know this reaction, BH3, the hydroboration, and the second reaction, oxidation. Hydroboration, oxidation, the same for the alkene. Also give you aldehyde. Look, give you aldehyde. Okay, not kuhul. Also not kuhul. Why? Also because the enol keto tautomerism, and we will take it inshallah. Now, the first one, addition of the hydrogen halide. Okay, the addition of the hydrogen halide. Look, the alkene undergo hydrohalogenation. Okay, the addition of the hydrogen halide HX on the triple bond. And he said, if you have 2 equivalent of the HX, it will be give you unsaturated. It will give you saturated compound with 2 vinyl halide. We said geminal dihalide. That meaning that both of the halogen atom bonded on the same carbon, bonded with the same carbon. Okay, we say this, it will be geminal dihalide. If you have of the hydrogen atom bonded to the same carbon. Now, the addition of HX to the an alkene is another example for the electrophilic addition. Why electrophilic? Because this nucleophile and the electrophile, it will be add on the triple bond. that we said electrophilic addition reaction. Okay, because the electrophile edge طبعا edge here, edge plus proton of the reagent is attract to the electron rich triple bond. Okay, that meaning the triple bond, it will be attack the proton. Here the reason here. And also we have two important note here. With two equivalent HX, we said both the hydrogen طلبة ومهمة, both the hydrogen atom bonded to the same carbon. Look, we have two equivalent. This equivalent number 1, this equivalent number 2. That meaning both the hydrogen, it will be added on the same carbon. Any carbon, less substituted carbon, the carbon with more hydrogen. According to what? According to the Markovnikov rule. The second note is that with terminal alkyne, look, both hydrogen atom bonded to the terminal carbon. Okay, the same thing. Why? Because the stability of the carbocation also according to the Markovnikov rule. Here, Markovnikov rule. This the addition of the hydrogen halide and the mechanism. I think the next is yes, here the mechanism. But we take this. Look, if you have this example, HCl, that meaning the H it will be here or the Cl here or reverse بالعكس. H here, the Cl here. Okay, now the first one is not so important because this is symmetrical alkyne. This symmetrical alkyne, that meaning this part exactly like this part. Okay, no different. Now check the first step, just check it. It will be hydrogen here. Look, hydrogen here, Cl. That meaning the triple bond convert to the alkene. Now, if you have another mole of the HCl, this addition, it will be according to the Markovnikov. That meaning this proton, it will become to here. Okay? That meaning hard hydrogen, both of the hydrogen atom, this and this hydrogen atom, this and this, it will be finally added on the same carbon. Look, on the same carbon. This step according to the Markovnikov rule. Now he said here, look to this terminal alkyne, HBr, that meaning this proton, it will become to here. Okay, and the Br to here. The next step also, the proton, it will become to here. Why? According to the Markovnikov, because the stability of the carbocation stability. And with one equivalent, yes, he said with one equivalent HX, the reaction stopped with the formation of vinyl halide. That meaning, طلبة, if you have just one mole, if you say one equivalent, that meaning one mole HCl. Okay, that meaning it will give you alkene. The halogen on the double bond, they said vinyl. Okay, vinyl chloride, vinyl halide, vinyl bromide. Okay, that meaning, what meaning vinyl? Meaning you have halogen on the double bond. Okay, also we have allyl halogen halide, we have vinyl halide. Okay, allyl is different from the vinyl, but I want from you vinyl, you have to know meaning, what meaning vinyl chloride or vinyl bromide. Yani in general vinyl halide, that meaning you have halogen on the double bond, directly bonded on the double bond. This meaning vinyl halide. The mechanism, you know the mechanism, no different, like alkene, just pi bond, it will be open, attack the proton, and give you carbocation. This vinyl carbocation. Okay, now the second part, the negative part, okay, it will be attack the carbocation to give you the final product. Okay, if you have another molecular HBr, that meaning also it will be the same mechanism. Look, this also the pi bond here, it will be open to attack the proton, okay, and give you carbocation. If you have طلبة, if you have here rearrangement, you have to check it. Okay, remember that we have carbocation. That meaning if we have this now secondary carbocation, if there is any chance or any way to make tertiary carbocation, make it. Okay, directly make it, because secondary carbocation more stable than primary carbocation, and tertiary carbocation more stable than secondary carbocation. Be careful about that, okay? Any reaction, you have carbocation, and there is any probability to make rearrangement, please make it. Here, secondary carbocation, there is no 1,2 hydride shift, 1,2 methyl shift, or 1,2 alkyl shift to make tertiary carbocation. There is no tertiary carbocation here. For this reason, we don't have any rearrangement here. Just the BR, it will be attack the carbocation to give you the final product. Okay, 2,2-dibromobutane. This is the final product. 2,2-dibromobutane. Do you understand this? Yeah. Okay. Now, if you look to this homework, draw the organic products from when formed when each alkyne, this is the below alkynes, you have 3 alkynes, is treated with 2 equivalent. Look, 2 equivalent, be careful about 2 equivalent with HBr, okay? That meaning, this alkyne, it will be react with 2 HBr and also another HBr. Also this alkyne, also this alkyne. Draw the structure, the products, okay? Draw the products. This is homework for you. Now, the second reaction is the addition of the halogen. طبعا طلب the addition of the halogen, there is no Markovnikov rule. Also, there is no carbocation formation. It is exactly the same rule when we use the addition of the halogen on the double bond. The same rule. There is no difference. Okay. Look here, you have a triple bond. Addition of X2, it will be give you X here and X here. Okay. It will be give you twice dihalide. Another X2, it will be give you tetrahalide. أكيد بيجت روجا نيروج دنك بقرا نيروج. Okay, دنك بقرا. Addition of the halogen, we said that meaning XX, it will be give you tetrahalide. Okay, this the addition, the same one. What is the mechanism? The same mechanism. We have a bridge. If you remember that, we have a bridge polonium ion. Okay, polonium ion. We take it. This is the mechanism. Yeah. Okay, this is the mechanism. Look, you have that meaning the pi bond, it will be attack the halogen. And you know, we talk about the halogens like Br2, Cl2. We said can be polarizable. Okay, what meaning polarizable? That meaning if the halogen atom come near from something high electronegativity or electron rich part, it will be for the few times it will be partially positive, partially negative. Okay, that meaning can be induced dipole. We say dipole. Okay, one end it will be partially positive and the second end it will be partially negative, and then in that time the reaction will be happened. Okay, in that time when it will be partially positive, that meaning the pi bond it will be open and attack the halogen for the partially negative part to give you the bridge. This is the cycle here, the bridge polonium ion. And then we have another negative part. This is the negative part, nucleophile. It will be attack the carbon, and the bridge it will be open to give you the first one of the addition. If you have another molecule of the halogen, that meaning also the pi bond, it will be at open attack, give you the bridge polonium ion, and the negative part that will be do as nucleophile also it will be attack the carbon to open the bridge to give you the final product. That meaning final product, if you look to the final product, we have 4 halogen atom, 1, 2, 3, 4. It will be added on the triple bond. Okay, the same mechanism. And look here, he said this homework, draw the products formed when this alkyne is treated with each reagent. Any reagent, Br2 2 equivalent, or Cl2 1 equivalent. Okay? That meaning this compound, the first reaction it will be react with the Br2 2 equivalent. The second reaction, no, this compound it will be react with Cl2 1 equivalent. What is the product? Right, that's the structure, okay? And he said here, the second one, explain the following result. Alkene are generally more reactive than alkyne toward electrophile, okay, toward the electrophile. The reaction of Cl2 with 2 can be stopped after 1 equivalent of the Cl2 has been added, okay, has been added. Think about that, and I want the answer from you. How? Okay, how? this homework for you. Maybe I resolved this homework on the PDF, maybe no. You can check it the PDF. Addition of water, the same. Also, the same reaction for the alkene, the same mechanism. There is no difference, okay? We also use the water here. If you look to the water with acid, we use acid as catalyst, okay? We use as catalyst. Now, because the water, just water cannot be react with the alkene, okay? Because the water is weak acid and weak base at the same time. We need acid here. We use the H2SO4 as the acid. Now, and if you look, this is just the triple bond. Okay. Now, look, if we added the H2O molecule on the triple bond, طبعا with the same mechanism, I will explain for you the mechanism. It will be give you the proton here and the OH here. Okay, open one of the pi bond. That meaning it will be give you this enol. What meaning enol طلبة? En يعني alkene. All يعني كحول, all. That meaning we have hydroxyl on the enol. طبعا طلبة hydroxyl طبعا high electronegativity atom, also with unship of electron, near from double bond, also the double bond with high electronegativity. That meaning slightly it will be not stable. Okay, not stable. If you have negative part here, near from the negative part, this we have negative charge here. Why? Because the electron. Also we have negative charge here. Why? Because we have unship of electron. Also we have oxygen with electronegative. This here it will be not stable. Not a stable compound directly convert to the ketone. How? This proton it will be come to here, and the double bond it will be formed here. It will be give you ketone. Okay, this enol keto form. Anyone is more stable, this more stable. Okay, this more stable ketone form, carbonyl group, this carbonyl group. Okay, it is more stable than the enol form. For this reason, the first time this it will be formed. Yes, this it will be formed and directly convert to the keto form. Okay, the final result it will be ketone, not kuhul on the double bond. Okay, not enol, it will be ketone. Okay, and for this he said H2O has been added. Okay, and be added on the triple bond. Okay. If you remember the alkene, طلبة, if you remember the alkene compound, if you have alkene, that meaning carbon-carbon double bond, and the H2O, it will be added on the double bond, it will be give you kuhul. Kuhul, if you go back to the reaction of the alkene, okay, the addition of the water, the hydration reaction. We talk about the hydration reaction. But here, no, we have a triple bond. That meaning the first step give you enol not stable, directly convert to the keto form stable compound. Look here, you have this H2O with the acid, it will be give you HOH. This enol not stable, directly convert to the keto form. Okay, directly convert to. Just طلبة, this proton, our proton, it remove and add it to here, and the double bond come to here. يعني isomer. طلبة, this and this is isomers, okay, isomers. But any isomer more stable, this is the isomer more stable. Now, if you have this, the H2O, the edge it will become to here, and the O edge it will become to here. This also enol. Ketoform, okay, ketoform, this proton come to here, and the double bond, it will be formed here. It will be also ketone, give you ketone. This ketone, this ketone. Okay. طبعا why this is the addition also according to the Marconi-Koff rule. Okay, why? Because we have HOH here, the H2O. The proton, it will become to here or to here. The proton, it will be added on the less substituted carbon, on the carbon with more the hydrogen. يعني according, طلبة, this according all this reaction, this step, you can write according to the Marconi-Koff rule addition. This important. You can make dossier خط سري. Okay, this is important. According to the Marconi-Koff rule. Okay, this the addition. How the mechanism? Here the mechanism. We will take it. But he said here the tautomers are constitutional isomers. Look, isomers. Yani this enol and this ketone, this isomers. That differ than location of the double bond and the hydrogen atom. What is the difference between this and this? Just the location of the double bond. Double bond here, double bond here. The proton here on the carbon, the second the proton on the oxygen. Okay, that meaning this isomer. Two tautomers are in equilibrium with each other. That meaning in equilibrium we have, look, that this are raw here on the right, on the left. Okay, but anyone is more stable, it will be long. This arrow is longer than this. That meaning this side is a prefer. It's a prefer to be ketone, not to be enol. And this is short. Look, this is long. This is short. Why? This is best figure, best isomer, more stable isomer. And it will be go to the enol. No, the enol is less stable isomer. He said an enol tautomers have, yes, we have hydrogen, oxygen, and the ketone, the hydrogen will become to here, and the double bond, it will be between the carbon and the oxygen to give you this carbonyl group. You can write here carbonyl group. This carbon double bond oxygen, we say carbonyl group. Okay, carbonyl compound. Maybe aldehyde, maybe ketone. Look to the mechanism. Look to the mechanism. This is the mechanism. This, طبعا طلبة, the first state, the water react with the acid. If the water react with the acid, give you what? Give you H3O plus. H3O plus, strong acid or no? Yes, strong acid. Strong acid. That meaning the pi bond, it will be attack the strong acid. طبعا acid-base reaction, no different. Okay, this acid-base reaction. And to give you carbocation, this is the carbocation. Okay, this is the carbocation. This is the carbocation. Now, the second one, this unshape of electron, it will be make for you double bond. Make for you double bond. This is about the alkene. Okay, make for you double bond. This enol ketone tautomerism. Okay, double bond, and the positive will be come to the oxygen. Now, the H2O, it will be remove the proton from the oxygen to remove the positive charge. Okay, this is the step. The H2O, it will be do as nucleophile, as base, attack the proton, and hard electron between the oxygen and hydrogen atom, it will be added on the oxygen to equal the positive charge to give you the final one, to give you the ketoform. This is the ketoform, ketone. Okay, that meaning if you look to here, a protonation of the enol carbon double bond with the acid. Okay, with the acid, and this acid, it will be form resonance stable carbocation. This is the carbocation, and with the resonance, this is the resonance here. Okay. Yeah. Okay. This the tautomerization of the acid. Okay. How the enol it will be ketone, طلبة. How the enol it will be ketone? By this two step. 1, 2. Okay, 1, 2. This is the tautomalism. Do you understand the tautomalism? I hope that. If you have a question, you can ask me. This is the tautomerization in acid by using acid. Okay. Now, look to here. Hydration of an alkyne. This full mechanism here for this slide. Look, you have a triple bond. Yes, that triple bond, it will be attack the proton and give you vinyl carbocation. We know that. And the H2O, it will be nucleophile, attack the carbocation, give you this compound. Okay, now, this isomer is stable? No, not stable, because we have the positive charge. That meaning the H2O molecule attack the proton, and both of the electron between oxygen hydrogen atom, it will be added on the oxygen to remove the positive charge and give you the enol form. Now, enol form stable? No, not stable. That meaning directly it will be entered to the tautomerization. Okay, directly by using tautomerization to convert from the enol to the keto form. Okay, it will be convert from the enol to the keto form. Now. Okay. Now, from the enol to the keto form by using this step 1, 2, 3. Talaba, this one step 1, 2, 3. This here we take it. This. Okay. By this 1, 2, 3. Tautomerization. This 3-state called tautomerization. It will be enol convert to the keto form. This. Look. Step number 4 and 5 is the tautomerization. That meaning, if I say to you, write the mechanism for the hydration of an alkyne, I give you alkyne. How many steps we have? 5. Step number 1, step number 2, step number 3, step number 4, step number 5. Okay, 5 steps. And look to here, draw the enol intermediate. Look, he said, write the enol intermediate. He said here, he wants the enol intermediate and the keto product. And then the enol will be converted to the keto form, okay, by using tautomerization from this following reaction for this. Number 1, the H2O will be added to give you the enol, okay, the enol. And the enol, how the enol will be converted to the keto form by using tautomerization. Okay, the same thing. The pi bond, it will be open, attack the proton, give you this carbocation, and the nucleophile attack the proton, and to make the double bond here, and the positive it will be convert to this to give you the keto form. Okay, to give you the keto form. This for you. Okay, this also nice homework. Draw the keto tomato for each enol. Look, Talaba, this enol form, all this is enol. I want from you to write the keto figure, the keto form or the keto tautomer for this compound. Okay. Now the second one, what two enols are formed when this alkyne is treated with H2O and H2SO4? That meaning this hydration reaction. Okay. Yeah, and that meaning if this alkyne entered to the hydration reaction, any enol form it will be formed. Okay. Draw the ketone formed from this enol after tautomerization. Okay, that meaning you have to make the tautomerization for this compound. This nice homework. Now here, draw two different enol tautomerism of this compound. This number 1. Draw two constitutional isomers that are not tautomers. I want to rather think about it is not isomers, but contain carbon, double bond carbon, and the hydroxyl group. Okay, think about that. The second one here, draw the mechanism for the following reaction, this reaction. Okay, or the mechanism. يعني how many steps? طلبة 5 steps. Okay, 5 steps for this reaction. Mechanism for this reaction, 5 steps. Remember that, 5. The second homework, draw the keto tautomer for each enol. I just give you enol. I want to write the keto tautomer. How? طبعا the double bond come to here, the proton here. This also, just the proton here, the double bond here is so easy. So easy. What two different, the final one, number 3, what two different alkyne yield to butanone, طبعا ketone from the hydration with the, we have hydration reaction here. Okay, that meaning I want from you to draw 2 different alkyne group. The result from the hydration is this ketone, 2-butene. Write the structure for this, and you can write the structure of the starting material can be interhydration reaction to give you this compound. Okay, that meaning this is a product I want from you to write the starting material, but 2 different starting material, not one. Okay, not one. And here the hydroboration oxidation. Hydroboration oxidation, we know. We take it before that, the hydroboration oxidation for the alkene, here for the alkyne. Okay, step number 1, the BH3, the H, it will be added to the more substituted alkyne, يعني أو عكس قاعدة Markovnikov rule. Okay, and then the BH2 give you the organoboron here, and then oxidation, just the BH2 convert to the OH. Okay, this anyone, this enol stable? No, directly go to the tautomerism to give you the ketone form. Okay, addition of the boron form an organohaloboron. Yes, the second one, oxidation with basic. Yes, we know that, form enol. Tautomerism of the enol form carbonyl compound, because the enol not stable, give you ketone form, give you the carbonyl compound. The overall result is the addition of the H2O to the triple bond. This overall addition of the H2O to the triple bond. Hydroboration oxidation of the internal alkyne form a ketone. Hydroboration of the terminal alkyne added the BH2 to the less substituted. Look, to the less substituted, يعني terminal alkyne. That meaning عكس قاعدة Markovnikov, reverse to the Markovnikov rule. You can write here, reverse to the Markovnikov rule. عكس قاعدة Markovnikov. Okay. Look here, I will give you this internal alkyne. BH3 H2O give you enol. Enol stable? No. Keto form, this is the ketone. This terminal, that meaning it also it will be BH3 second step, the same thing. That meaning the OH, it will become to here. عكس قاعدة Markovnikov rule طلب. Also give you enol. Enol stable? No. It will be converted to the keto form. Okay. This also 2 examples. He said the hydration with this. Yes, we know H2O with the acid, and oxidation with this. Both the element H2O across to the triple bond. Yes, we know that. It will be added to the double bond and give you keto form because the tautomers. Look here. This example, what we talk about this example, he said this, you have this alkyne, okay? One times it will be go to the hydration, this hydration, or this hydroboration oxidation. What is the difference? You will be see the difference, okay? This hydration by using acid according to the Markovnikov rule. This hydroboration oxidation عكس Markovnikov rule, okay? Now, this hydroboration according to the Markovnikov rule, that meaning we have HOH. H, it will become to here, and the OH, it will become to here, huh? Give you this compound. This is enol form. Stable? No, not stable. It will be give you keto form. How? This hydrogen will become to here, double bond here, it will be give you ketone. Now, look to the second one. Second one, hydroboration, this is the hydroboration. The BH2 come to here, the hydrogen here. يعني عكس قاعدة Markovnikov rule. And you give this compound. This compound, oxidation, give you enol form. Look, the hydroxyl group on this carbon, not on this carbon. عكس this compound بالضبط. Reverse to the Markovnikov rule. Now, enol form stable? No, not stable. It will be give you keto form. This keto form. Okay, that meaning this proton come to here and the double bond, it will be convert between the carbon oxygen, give you also carbonyl, but anticarbonyl aldehyde. This anticarbonyl ketone. This aldehyde, this ketone. Look, it will be different. It will be different. There is different. If you have addition like Markovnikov rule, if you have addition reverse to the Markovnikov rule, that meaning the product, it will be different. Exactly, 100 by 100. And here he said addition of the H2O using acid, forming ketone from the terminal alkyne. Look, he said, if you have terminal alkyne, طلبة, all the terminal alkyne, the hydration with the acid give you ketone. The hydroboration oxidation give you aldehyde. All the time, terminal alkyne give you ketone with hydration. With hydroboration oxidation give you aldehyde. All the times. Okay? Yani, if I give you terminal alkyne, I want from you aldehyde, remember, you have to do hydroboration oxidation. If I give you terminal alkene and the product is ketone, 100 by 100 is hydration by acid. Okay? This is so important, طلبة. Here, also here, the addition with the H2O by using hydroboration oxidation give you aldehyde. This draw the products from the formed. Yes, any product will be formed when the following alkyne are treated with each set of the reagent. If you have طبعا this alkyne, يعني you have this alkyne, one reaction or one times it will be react with this, and another reaction it will be react with this. يعني one of them hydration, one of them hydroboration oxidation, and the second one also B react with one, also this B react with two. Okay, I write to draw the product. يعني how many products we have? You have 4 products, two from this, two from this. This homework for you. Okay. Now the reaction, we talk about acetylide anion. Yes, at the first of this lecture, we say the terminal alkyne is acidic, can be react with the base to give you acetylide anion, and then the acetylide anion, it will be do as nucleophile to attack alkytrophile. You know that. Now, why it will be useful for any, طبعا here said for any times will be taken. He said terminal alkyne are readily converted to acetylide anion with strong base. Okay, with strong base. Why strong base? Because terminal alkyne is weak acid, needs strong base. Okay, such as NaNH2. طبعا طلبة NaNH2 strong base, also NaH strong base. H minus الhydrate طبعا. Hydrate is very strong base. Okay, so much. Now, this anion are strong nucleophile. Yes, it will be attack the proton of the terminal tank to give you acetylide anion, and the acetylide anion it will be do as nucleophile, can be attack alkytrophile. If you have alkytrophile, that meaning this acetylide anion can be attack the alkytrophile, and we will have finally what we have. We have carbon a new bond. We have a new bond here. Okay, that meaning your molecular structure or your molecular weight, it will be increased. Okay, this molecular weight, for example, 100, but finally it will be 120. The molecular weight. That meaning increase the molecular weight. What meaning? That meaning increase the structure, the size of structure. We have carbon a new bond. Okay. Now reaction acetylide anion with alkyl halide. What we remain here, reaction, and also this homework, reaction acetylide with epoxide. Okay, طلبة. I will stop here, طلبة. Reaction of acetylide anion, because our lecture is just 1 hour. I will stop here. Okay. And inshallah continuous with the next lecture if we have a chance to meeting another again. Okay. And if you don't have a question, I hope you understand this lecture. If you don't have any question,